All right, guys, welcome to week 6 FRQ notes. Let's go ahead and take a look at our first one here. So we've got let's read the story here first. A metal wire that's 8 centimeters long is heated on one end, and the table above gives selected values of the temperature, which we're going to call T of X, and that's in Celsius degrees. So this table above gives the temperature of that wire X centimeters away from the heated end. So you guys can imagine if you have a wire and you put a fire next to it. That's my fire there. It's going to be really hot here, and as you get farther away, it's going to get colder and colder. So that's the idea there. So at a distance of 0 centimeters away from the flame, it's going to be the hottest, 100 degrees Celsius, and at 1 centimeter, it's dropped down 7 degrees, and by the time you get out here to 8 centimeters, it's 55 degrees. So that's the table we're looking at. They tell us that the function t is decreasing, which is obvious. It's going to be going down as we get farther away. And then they tell us twice differentiable, but that kind of doesn't really matter to it a whole lot, honestly. So we're going to go ahead and move on here. So the problem says find this and indicate the units of measure. And then they also want us to explain the meaning of this in terms of the temperature of the wire. So we've got 3 things that we need to do here. So first of all, let's start off with the integration. So I'm starting off with my expression here, the integral from 0 to 8 of t prime of x dx. Now, when you integrate t prime, that becomes normal t. Okay, so when you integrate a derivative, you get its antiderivative, right? So if t prime is the derivative of t, then when you integrate t prime, you get just regular t. And the 0 and 8 go out here. So after you take the integral symbol is gone, and now I'm going to put these limits of integration on the right side, just like that. And then using the fundamental theorem of calculus, then we can plug the upper limit in first, and then the lower limit in last. And from here, we're going to use our table. What is t of 8? So basically, what we have to do to answer this question is you have to find where 8 is at in your table for the distance, and then you look at the t value that goes with it. It's 55. So this one here is 55 minus, and then t of 0 is 100. And then we can just go ahead and do our math here. 55 minus 100 is negative 45. Now we've got a number here, but we need to do a couple of things with this. So this is part of my answer here. This would probably be worth 1 point, just getting that in there. I think I'll move that over here, actually. But that'd probably be worth 1 point, because they said find this, and we just did it. It's negative 45. Now, they also want us to indicate the units of measure. Well, this is kind of difficult to see what the units of measure are right now. But by the time we get here, hopefully we kind of see it. I mean, we're getting 55 and 100, and those numbers are right here. So what are the units of those numbers? Well, those are degrees Celsius. So we have our units. It's degrees Celsius. Okay, so that would be worth another point, making sure you recognize that. So whatever these are here in your table, in this case for us right now, it's degrees Celsius, that'll tell you what your units are. So those are my units. So we've got 1 point for the number, 1 point for the units. The last thing we need to do is explain what this means. Well, basically what we're looking at here is this thing right here. This is the temperature. Now, you guys don't need to write this. You can, I guess, for your notes, but it's not really part of the answer. But T of 8 is the temperature at 8 centimeters. So T of 8 is the temperature of the wire at a distance of 8 centimeters away from the heat source. Okay, So hopefully you guys understand what this is then, right? This one here, T of 0, is the temperature at 0 centimeters away from the heat source. Okay? So that's what each of these pieces mean. But what does it mean when you subtract them? Well, if this is the temperature at 8 centimeters and this is the temperature of the wire at 0 centimeters away from the heat source, then what does this negative 45 mean? Well, basically what it means is that the temperature has dropped because it's negative. The temperature has dropped 45 degrees on the interval from 0 centimeters to 8 centimeters. So you don't need to write the red part in your answer, although it might be nice to have in your notes. But our final answer is actually going to be the following. It's going to be the temperature dropped 45 degrees Celsius from x equals 0 to x equals 8 centimeters. Okay, now they didn't use the word interpret this time, but that's really what we're doing is we're interpreting. And as we've interpreted in our last FRQs, you know we always need the context. So that's this piece here, the temperature dropping. And then we also want to include, I'll highlight these parts, the temperature dropping, that's the context. Then we want the output units, 45 degrees Celsius, and the input units, which is 0 to 8 centimeters. So this is a lot like an interpretation here. And that would also be worth 1 point. So this would actually be, by my estimation, this would be probably a 3-point question, possibly 2. They might not give points for the units if, like in the other parts of the FRQ, they already did that. But if they hadn't asked for units anywhere else in the FRQ, as you guys can see, this is part C. So there was an A and a B before that. So if they hadn't asked for units before that in a similar context, then they might have then they might give you the point here for this. So this is either a 2-point or a 3-point question. So you get 1 point for getting the answer, 1 point for the units, 1 point for the interpretation. So there's that one. Let's go ahead and move on to our next part. Number 2. So this one says that f is a function. It's twice differentiable. Once again, we don't really care about that right now. The table above gives values of the f for selected points in the closed interval 2 to 13. These are x values. So we're going from 2 to 13. That's what they mean by that. Intervals are always in terms of x. So basically, we just have a function here where they tell you a couple of x and y pairs. So here's x, here's y, here's x, here's y. So, if you wanted to, not that we need to, you could plot those points and graph it and have a picture of what that function looks like. But we don't really need to do that. This question here is asking us to evaluate this integral and to show the work that leads to our answer. So the first thing I'm going to do on this one is I'm going to apply some properties of integrals. The first thing I'm going to do is I'm going to distribute this integral in here to these separate pieces. And so that's going to look like this. Now, even though there's one dx up here, if you're going to split this up into 2 separate integrals, technically you should have a dx on both of them. And that just reminds us that we're integrating with respect to that. Okay. So let's go ahead and do this. The integral of a constant number, well, if you integrate a constant, you just put an x next to it. This one, the constant doesn't really matter. In fact, if you want to, you could just cross that off and put it out here in the front as a multiple. But it doesn't really matter if you leave it in there or not. But the point here is that when you integrate f prime, you get just f. Because remember, the integral of a derivative gives you the antiderivative. Okay, so once again, that's from 2 to 13. So now we're going to do the fundamental theorem of calculus on both of these pieces here. So first of all, we have this 3x one here. I'm going to widen the brackets there. So we're going to have 3 times 13 minus 3 times 2. So why do we have that? Well, according to the fundamental theorem of calculus, you plug in your 13, you plug in your 2, and you subtract those two results. And that's for this whole thing there. But we still have this minus, and we still have this whole bracket set here with a 5 in front of it. So for this one, it's going to be f of 13 minus f of 2. Okay, so let's go ahead and start simplifying this out a little bit. 3 times 13 is 39 minus 6. Now, as for these guys here, f of 13, we're just going to look at our table. Here's where x equals 13, and we want the f value that goes with it, and so that would be 6. For this one, we're going to look for where x equals 2 and look for the f value that goes with it. Here's where x equals 2, and here's the f value goes with it, so that's 1. And then we're going to keep going here. We have 39 minus 6, which is 33, minus 5, and 6 minus 1 is 5, and 5 times 5 is 25, and so we end up with 8 as a final answer. Okay, so basically I just took the integral of each of these pieces separately, and then I did the fundamental theorem of calculus on each piece, and then I just simplified my work. And remember, for these pieces here, you have to look at your table to get the information that you need. All right, and so that will do it for us on our FRQs for this week. And good luck on your practice. If you have trouble on the practice, just come hang out with me after school on Monday. We'll help you out with it. All right, have a good one. We'll see you then.